Word problem involving a sine or cosine function, problem type 2. Again, you can see I have a problem already teed up, so let's just dive in. The depth of water in a bay varies throughout the day with the tides according to the function h of t equals 12 plus 6.5 times the sine of 0.25t. We're asked for four pieces of information: the minimum depth, the maximum depth, the period, and the frequency. Two things that I have not mentioned here. The depth of water, h, is measured in feet, and the time t is measured in hours since their um, most recent settle point. So, probably since dawn, it doesn't really say, it just says in hours. So, the minimum depth and the maximum depth are pretty straightforward. My variability in this expression all comes down to sine. And sine varies between -1 and +1. So at its smallest, h of t is going to be 12 plus 6.5 times -1, and at its largest, h of t is going to be 12 plus 6.5 times +1. 6.5 times -1 is -6.5. 12 minus 6.5 is 5.5. 6.5 times +1 is 6.5. 12 plus 6.5 is 18.5. So the minimum is going to be 5.5 feet. The maximum is going to be 18.5 feet. The period and the frequency can both be determined based on the argument inside of sine. Right? Frequency is simply the reciprocal of the period, and period is 2 pi divided by the coefficient inside the argument. So let me get the depth out of the way here so that we can finish this problem off. The period is 2 pi divided by the argument, the coefficient of the variable inside the argument of the sine function, which in this case is 0.25. And 2 pi divided by 0.25 is 8 pi, or if you prefer a decimal approximation, it's about 25.1. The frequency is simply the reciprocal of the period. So since we calculated that the period is 25.1, the frequency is 1 over 25.1 somewhere in the ballpark of 0.0398. The units on the period are whatever our time step is, so in this case that's hours. Frequency is cycles per time step, which in this case is hours. So roughly 0.04 cycles per hour is the frequency here.